Hello, I don't know wherever you are, if this is morning, afternoon, whatever, I'll greet you by that. Good morning, or say good afternoon, or say good evening. It depends the time when you're watching this video. Welcome back into our discussion on mathematics, that's Form 3. As usual, we want you gentlemen, ladies, youngsters to be together in the discussion about mathematics, that's Form 3. Remember, by the previous videos, we are introduced into a new topic about sets. So if you can go back, in case for those people who are joining us today, follow the videos. There are at least 2 videos which we have already discussed about the sets, so that when we discuss something today, we should be able to go by it together. Like there's the link down here that you can use and watch all the videos. Right, now without wasting time, let us continue from where we stopped. But now we cannot just start the new section before we go through what we discussed. You know, maths is connected. We cannot just start from anywhere else, but we need to start from the scratch. So here introductory, I will first of all try at least to remind you what we discussed in the previous video about the sets. Right, so what we did that time was firstly to define what a set is. So we really discuss and we define the set as just like a collection of objects, right, of objects, or call them as members, right. So that's it, what we defined that time, and we gave several examples of sets. Like this time around, I don't think we should have that need to give example, but you can have so many as much as you can. Right, so going through it, we also discuss other issues about the more like types of the sets. We talked of issues about the complement of a set, complement of sets, right, which are denoted by the symbol. Say for example, I've got set A, and here we light an apostrophe on top. So if we light a set represented by a letter, say maybe A or whatever, and there's an apostrophe on top of that letter, that simply means complement of a set. That is the category of a set. For this one, we said the sets whose elements are not found in this particular set. So which means this set is compared with a what we call it the main set. That's a universal set, right? And also we talked of the cell, that's a universal set, right? That is always there. Each time we'd like to discuss about the complement of set, we first of all talk of the universal set. Universal set is just like their main set, a set that contains the other sets. So it's just like a set that contains minor set. Like say for example, I gave you a good example that time. We can have a Form 3 class. A Form 3 class just like one block, a collection of objects, whereby the objects themselves can define them as students. So if you look at the students, you find that the students can be categorized into 2 categories. One can be a group of boys, and another one can be a group of what? Girls. So you find that a group of boys form its own set, group of girls also form its own sets. But the 2 are found in one what? That's a class, and that class is what is defined as what? Universal set. So that's why you can simply define universal set as just like a main set that contains other sets. You can further even divide the students themselves into minor sets. You can go by maybe church denomination. You find that the category of students will be there of a particular denomination, made by CCP, talk of Roman Catholic, talk of maybe Seventh Adventist, but all of them, they form one main set. That's the set of the students. So that's it about the universal set. But if you talk of a complement of a set like set A, it means elements which are not found in particular sets. So they compare that one with the main set as such. We also discussed something about the union of sets. Union of sets, right? And we talked of it about the union of sets. We said that union of sets is just like a combination of elements of given sets. So for example, I have got set A and set B. It means if you talk of set B, that set B have got what? Elements. And also if you talk of set A too has got what? that's elements. So if we combine elements of A and elements of B together, they form what is the union of sets, right? We also talked of something about the intersection of sets, right? In the intersection, we said we are looking at the set whose elements are common or say found in particular sets of interest. Say for example, I've got set A with elements indicated, set B elements indicated. So if you talk of the intersection of sets, it will be a set that has elements which are found in A at the same time they are found in what? In B. That's the intersection of sets. So these ideas are also needed today in the section that we'll discuss very soon. So please, students, try to understand what it means by all these categories of sets. Talk of the inverse of set, talk of the complement of a set, talk of intersection of sets, talk of the union of sets, and with the symbols attached to say what is the symbol representing the intersection of sets, what is the symbol representing the union of sets, and what is the symbol that is representing the inverse of set. It's very, very, very important in the discussion of sets. Right. So today we will not even talk something that is difficult or say maybe special. They're just like the same issues about the sets. Right. Today we'll be discussing something about the Venn diagram in the same set theory. Right. So we are going to define what a Venn diagram is and then see how important this section is how important this section in the discussion about sets. Right. So here we are. Based about the Venn diagram. Right. I will define what a Venn diagram is, and thereafter we need to see how this Venn diagram is important in the set discussion. Right. Remember we discussed something about the inverse of set. Right. And we say the inverse of set is just like a main set that contains minor sets or say other sets which are defined as subsets. Right. Now, if we talk of the inverse of set being a main set that contains minor sets, like as I gave you an example about the class, or else let me just give you a good example here of a set, like say for example, here I've got a symbol for inverse of set which has got elements like 1, 2, 3, 4, 5, 6. These ones are natural numbers. And then out of that I have got other sets like talk of set A with elements like 2, 4, 5, and also I've got another set B which has got elements like talk of 3, can talk of 5 itself and 6 and what have you, maybe 1 again. Right. You'll be able to see that set A has got elements 2, 4, 5 which are found in this inverse of set, and also talk of set B has got elements 3, 5, 6, 1 that are also found in the same inverse of set. We consider A and B being the subsets of this main set. Right. So now, if we connect this discussion here about the inverse of set and these other minor sets which call them as subsets, we will try to connect here what is it about the Venn diagram in relation to this. Right. So if we look at this, we are just like breaking the main set which is the inverse of set into parts. Right. So this presentation in one way or another, we can manage to represent it in the form of the diagram. Right. And this diagram that will be used to present the sets, this type of diagram is what is known as a Venn diagram. Right. This diagram just shows the relationship thus existing amongst the main set which is the investor set, and also the what? The subsets, which are just like minor set. So just like the moment I can present the elements of the investor set like 1, 2, 3, 4, 5, 6 like this by listing the elements as such in the curly brackets, and having the minor sets like A 2, 4, 5 and also B 3, 5, 6, 1. It means there's another way how I can represent this one out, and this is by using the what? The diagram, and that diagram is what is defined as what? The Venn diagram. Like, so simply the Venn diagram can just be defined as the diagram that is used to show the pictorial relationship amongst what? The sets. Like in this case we are referring to the sets such as the main set and also its subsets. So we'll be there now having some sets which are given in the Venn diagram, and also be asked to present these sets in the form of the diagram. So it's just like how do we draw such diagrams in order to present the sets as we have them here. We have the investor set, we also have got the minor sets. So that is our discussion of today. Right. So before we proceed, can I just have to give you at least a definition tentatively of a Venn diagram. So this you can take it just like diagrams that show pictorial relationship among sets. Right, so we talk of the diagrams that shows the pictorial relationship among sets. So here we are referring to the what? Subsets, and also talk of the what? The universal set. Right. So that's it about a Venn diagram. It's not something that is new. It's more like when you see the Venn diagram, it's just like you see the investor set itself. So you just break up the members in the investor set into parts and present them in the form of the what? Pictures of some kind. Right. So let's see how these diagrams are being drawn. Right. So aside here, I have got 2 examples that we are going to use in the first discussion, where we can be able to know how to draw the Venn diagrams, or simply just like presenting the elements of the set in terms of diagrams aside. That's what it means here. Right. First category of the presentation, it will be about problems which has to be presented in a 2-set problem. Later we'll look at a 3-set problem, meaning to say we'll have first category about the Venn diagram that will only talk about the relationship of sets that can be presented in the form of 2 sets. Later we'll be looking at the diagram that will be able to present the elements in the form of what? 3 sets. Right. So like here, let's have this example. It's about a 2 that's a set problems. Right. So what it means here is just like a matter of say breaking the elements that's of the investor set into 2 minor sets, and the other one, the last one, by the objectives themselves, remember indicated drawing the Venn diagrams of the 3 sets, they will be looking at a 3-set problem, where it means elements of the investor set will be broken into 3 that say minor sets, or stock of what? The subsets. Like, so these are just like the kind of sets that will be moving up here in our level, that's say from 3. That's a Venn diagram that talks about the 2 set problems, and the other one it be about the 3 set problems as such. Like, so our knowledge should be at least attached to that. So like here we have first problem where we are given set A and set B, which are subsets of a natural number. Right, here we have set A and set B, which are subsets of natural numbers. So which are these numbers? We're given here. First, we have set A that telling us set A is defined by this set builder notation. We have got, say, natural numbers. Simply here, I know this time around you are able to understand what it means by set builder notation, and you can be in the position to list up the members. Like say for A here, they're trying us simply to say we have got natural numbers which are between 1 and 7. Right. So remember how to read this one out verbally. It tells us to say sets of A such that X is a natural number that is in between 1 and 7. We also have another set B defined by this set builder notation. It also gives us some bounds of the natural numbers which are defined here. To say X is just like an element of natural numbers that is in between 2 and 20. But now this type of natural numbers are specifically referred to a certain category of numbers which are even numbers. So it's not just any number that is between 2 and 20. But the numbers which are between 2 and 20, we're talking of only those which are what? Even numbers. So this one we are given here. So now the question comes in first. It's about the elements themselves. They're asking us first of all to list the elements of A and the elements of B. Then thereafter, we are asked to show these elements in a pictorial diagram, which we call it what? A Venn diagram. Like that's why the second question asks us to show the sets in a Venn diagram as such. Right. So now let us see how we can handle this one out. Right. So for question A, we have set A, which is defined by a builder notation. Defined by let's say X is such that 1 is equal to less than X. At the same time, X is equal to or less than 7. Right. Understandably, it's just like X is bounded, is in any number, all numbers which are in between 1 and 7. But these numbers should be natural numbers. So here we don't talk of decimal numbers, just talk of the whole numbers side. So if now we are to list the elements of A, simply by the discussion, it means what we want to have here are the exact number themselves. We need them to have their as a list, not just like a bound, as it is represented by a that's the set builder notation. So here, if you talk of numbers which are in between 1 and 7, we may be able to appreciate by these types of inequalities that say X is equal to or greater than 1. It means 1 is included here in the list. That is the number that we're going to start up with. And here when we talk of X is equal to less than 7, it means the X is one of the natural numbers that also includes a 7. So which means here the list will start from 1 up to 7. We start from 1 up to 7. 1 and 7 are included. So if we are to respond to these elements of A, will be numbers such like 1. Then thereafter we'll talk of a 2. Then we'll have a 3. Then we'll have a 4. Then we'll go to 5. Then we'll have 6. Then we'll have 7. Right. So those are elements of A. So if I look at this, it simply means the list goes something like this. Right. Going to B, we also do the same. B, we talk of a bound between talk of 2 and 20. Right. Which means 20 and a 2 are also included. Right. But they'll be included only if those numbers are also defined by this statement here. We just look for the numbers which are even. Right. Numbers between 2 and 20. So now, as you'll be listing, you will be having the list from 2 to 20. Try at least to suss out, are these numbers even? Right, because you may end up just listing even numbers. We've studied in the first one, we've just listed all the numbers starting from 1 up to 7, because here there are no limitations here. But in B, there are some limitations. We don't want all numbers which are between 2 and 20. We only need those numbers which are even. So now, here, before you start listing the natural numbers which are even, you first of all have to be sure in the definition of even numbers. So you need first of all to know what even numbers are. Right. So by Form 1 work, we will be able to appreciate that even numbers, we talk of all numbers which are divided by 2 and leaves a remainder 0. Numbers divided by 2 leaving a remainder as 0. Right. So if we are to assess from 2 up to 20, we have numbers like a 2 can be divided by 2 and the remainder is a 0. And we go on. We have a 4. We have got 6. We have got 8. We have got 10. We have got 12. We have got what? Talk of 14. We have got 16. We have 18. Then finally we have got 20. Right. Other numbers less can be divided by 2, but they leave a remainder apart from 0. Right. So list of B is this one here, has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 members. And A has got 1, 2, 3, 4, 5, 6, 7 as the members. Right, so that's it about the first question, where we asked only to list the elements of A and B. Right, so now according to what we have today, our main emphasis is to present these sets in the form of a diagram, but the definition just like pictures. Right, so it's like now how do we present this entire set builder notations of the set A and B, which are part and parcel of the what universal set, which is a universe, is a set of natural numbers. Right, so how we do here, this is the way we handle this one out. Maybe because of space, let me just lab first part of the information here. Allow me first of all to relight the sets up here. For A, we have 1, 2, 3, 4, 5, 6, 7. Right. For B, we have that's 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Right. These are elements of B, beginning from a 2. Right, so here we would like just to present those sets in the form of a diagram. Right, how is the Venn diagram drawn? Like, there are several ways how you can draw it, but preferably we really choose to use a special shape. Right, remember when we talk of a Venn diagram here, from what I defined, it's more like you are considering the main set, which is like a universal split into minor sets. So that is what should be there in your head. When we talk of Venn diagram, we are just referring to the universal set as such, which carries the what? Minor sets, which are subsets aside. So like here, the universal set is regarded as the entire set of natural numbers. But now the subsets here are categorized as what? A and B, which are part and parcel of what? The universal set. So how we draw the diagram here, this universal set, the main set, as the set of the natural numbers, is represented by a rectangular, that's a shape, which looks something like this. You're going to draw a rectangular diagram. This now is about the Venn diagram, right? Which goes something like this. Right. It's more like in the classroom, where we have good boys and girls. The entire class can be drawn like this. So it means just class, we have got set of boys and girls. So it means we have got set of boys and the set of girls like this. So that's the way it is. So you can tell the entire class is just by a rectangular figure, but these circles are just like different, make it different. But we're still more talking of the elements of the same what? Universal set. So this is a set of boys, that is a set of girls. It goes like that. So these are like a subset, but this one is a main set. So the Venn diagram here is just like a composition of two shapes, One is a rectangular figure representing the investor set, the main set, and the other circles here are representing like what? The subsets. Right, so this is the understanding that we have it here. So we do it similarly in this example. If you look at this rectangular figure, this one is the investor set, and you can have a symbol written on top like this. So I draw this shape, take this one as the entire investor set of the natural numbers. But now out of these natural numbers of our discussion here, we have got the minor sets which are of our interest. This is set A and set B. So which tells us that A and B are found inside the what? The investor set. Right, so how do we contain A and B inside? So since here we don't want to just write A and B aside and have a list like that one separately, we'll talk of the pictorial presentation. It means these ones are subsets. We need also to have a special, that's a shape that can be used to present their members. So what we prefer here, it means inside, since these A and B are found inside the investor set, it means we have special shape, and usually here we use circles to represent A and also we represent the B. So since we have got A and B for the natural numbers, it means inside here I'll write one circle of one category, which is A, and another one forward for B, like that. Right. So which means what I need to do is amount of listing all the elements which are found in A. I'll write them in this set, in this circle, and the elements of B, I'll write them again in what? In this what? Circle. But now if I found that there's some elements which are found in A and B, it means in this case it tells us a situation that we had that at the time when we were discussing about the intersection of sets. So I need also to show that some elements are found in A and B at the same time, and this one will only happen when I intersect the circles like that. So that talks of the intersection of sets. So the space that we have here in the middle, here I will list all members which are found or contained in A and what? B at the same time. Right, so now before I intersect these circles, I first of all have to check up there. Do really I have members found in A are also found in B. Right, but if they are not, it means the circles will be drawn like that. They'll never intersect and they'll not even touch. Right, so now if I go up there, I'll find that set A has got members 1, 2, 3, 4, 5, 6, 7. But now if I trace a 2, look at a 2, I look at 4, again a 6. I found that these members are also found here. There's a 2 here, there's a 6 here, there's what? Not 8 here. We have got a 2 here, there's a 6 here. There's also a 4 here. Right, so that tells us, here we talk of the intersection of the two circles if we're going to represent the members in here. Right, so what we have is something that we go something like this. The choice is to intersect the circles like this. Right, so that we should have a certain section that is just like an area in the diagram here that is found in both sets, that is A and B. Had it been note that we don't have the members found in A and B, as I already said, it means the circles has to be disjoint. They have to be drawn separately. Because what we want is we don't have to repeat the light up. That if we have got A, we write the elements separately, and the same members are also found in B, we also write them separately. No, we don't do that. But what we have is when we have got members found in both sets, we intersect the circles as it is. So now here we go. Once we have intersected, the first thing you do, can first of all write all the members which are found in both sets A and B. So what you do, you take this space here, considering found in A and B as intersection. So we have the numbers like 2, 4, and 6 fixed like that. Right, so that when I talk of A, I'll talk of A has got 2, 4, 6. I talk of B, still have got 2, 4, 6. Right, so this remaining members has to be written in a circle where they're supposed to be found. Like say for example, here the moment we have removed a 2, 4, and 6, we have got 1, 3, 5, and 7 remaining in A. So I'll write them here as 1, talk of 3, then 5, and 7. we write on this space here, because this space here is just like solely found in A. So we say A only. This space is for A only, but this one is for both A and B. And this space here is only for B. So what we do here, we are going to write all elements which are left in B, apart from removing the 2, 4, and 6. So we come and check here, some the 2 has already been written, 4 already written, 6 already been written, but what we're remaining up with is 80. So I write 8 anywhere in that space. Then have a 10 written like this, 12 somewhere, 14 somewhere, then 16, I write it here, 18, I write it here, and finally I have what? A 20. Right, so if we can at least have a closer look at what is here, you'll be able to see that we have managed to fix the elements in A and B into the diagram, which looks more like this. Right, so try to define it in such a way that, say, when you see the circles inside that bar, that rectangular shape, consider them as the subsets of the entire set of the what? Natural number. Right, so this, I repeat, the rectangular shape talks of the main set, which is the universal set, while these circles for A and B are talking about the minor sets, which are known as the subsets. So this is the way we draw the Venn diagram. A diagram representing the relationship among the sets. So here it means we're talking about the relationship that exists in A and B and the entire set. So the relationship can be described there. You'll be able to say that there are some members which are found in both in A and B. You explain the relationship. Somebody will ask you, how many are there? You'll be able in the position to count. We have got A, we have got 2, 4, and 6. So you have got 1, 2, 3 members there. And you'll be able again to find out how many members are there in total. Or say somebody must ask you, can you give us maybe the total number of members in the universal set? You'll be able to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Because all members which are here are defined by the universal set. So universal set is split into categories of A and B. Let's try at least to analyze the presentation as such. Right, so that's it for example 1. Can we now go to example 2? Right, having now an idea on how a Venn diagram is presented. Right. For example 2 is a diagram which has already been presented based on the first example. So it's more like we're there just going now to answer the questions as they are. Right. They say use a Venn diagram to answer the questions that follows. So you can see here we have got a rectangular box which is like a universal set based on the first example's discussion. And when you see the inside circles here, they say circle A and the circle for B, those are just subsets of the entire universal set represented by the rectangular shape. So we already have here in set A, we have got A, X, N, and Y, which are found in what? This space here. No space of B is passing through this one. So you can say these elements are found in A only. And again in B only, we have got K, T, J, and D in B only. But now what is found in both sets A and B, you'll be mentioning of B, C, and F. At least try to discuss the spaces which are there. But now if you look at the outside space here, outside the circles, that tells us members which are not found in A and B. Like what? Say for example in class when you can talk of students who like football and netball. You find that we may have several students in the classroom. If you have got those who like netball, they'll be somewhere there. And those who like football, they'll be at a certain position there. But there'll be still more some who don't like any of the games. So they're just outside. So those ones are the ones which can be written outside here. But in this case, it means all learners, in this case, these are learners, are categorized into what? 3 main phases. Those who like both and those who like just a specific what? Maybe talk of a game. Right, so you can describe the meaning of those elements by particular categories of sets as such, A only, B only, A and B, things like that. So now, the question here is simply direct, because some questions come like that, they already give you the Venn diagram, and they need you just to analyze and answer the question as such. The first question is here to ask us and find the all elements which are found in a complement. By the introduction, I mentioned what this one means. When you have got the letter representing a set and the apostrophe is attached on top, it means what is not contained in A. What is not contained in A. Right. So how to respond to this? From the Venn diagram, what is not contained in A? First, check and find out what is found in A. So here, when you come here, you'll be able to see that A is this circle here. It even gets as far as into B. So in A, if you look at this circle, has got this, and that as elements. But what is not in A? You talk of K, T, J, and D. So here it means if you talk of complement of A, we'll talk of elements such as K, T, and what? J and D as such. Right, what is not contained in A? Going to B, we have got A, this means union B. You can also list the elements of A union B. Remember, by A union B, we are talking about the elements which are contained in both A and B. That's like a combination of elements in A and B. So combination of elements in A and B, it means all of these ones here. All of these ones, A and B. Elements in A, elements in B combined. So which means what we have here, we talk of A, X, N. If I would begin with set A, then talk of Y, then we get into the part where it is the intersection for both, talk of B, talk of C, talk of F. And this has to be combined with B, we talk of a K, then we come to T, then J, then finally D. Right. So that's it, defines the A union B, combining the elements together. And then now let's go for C, right, which is B in this case. Of course, let B, but this was supposed to be C. That doesn't matter. Right, let's go for A, then this symbol and a B. Right, but what we've just discussed, this symbol simply means intersection of sets. Right, what is the intersection? What is found in B and what is also found in A at the same time. Common elements. So if you check in the Venn diagram, you find that it is this part here that is defining the intersection. This part here. Look at this part here. This part here. This B, C, and F. If you look at this space here, is the space which attached to A. It is also attached to what? To B. So we have got B, C, and F. So write a B, C, and F like that. Finally, we have now that is the D. They ask us to find the number of elements in the universal set. Right, number of elements. This simply means number. You have to count how many are there in this set. So this set is the entire diagram here. The universal set is the diagram itself. What is found in this what? Diagram, in this rectangular shape. So this rectangular shape signifies the universal set. So what is found in here are all elements that you see them here. So if you ask you to count how many elements are found here, is as good as just counting the union of A and B. And if we have got other elements outside, we have also added in the discussion. Right, so here it means number of elements in universal set represented by the entire diagram here. It means you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here you just write 11. Don't write the curly brackets. If you write the curly brackets against 11, it means you are talking about the what? Set itself. But here you're just looking at the number of elements. Right, so students, this is just like briefly how we can define a Venn diagram, and by the examples I think you are able to get the sense to what exactly it means by a Venn diagram. You really appreciate that the Venn diagram is more like description of the universal set that is able to split the subsets into categories. So pictorial presentation, this is what we are trying to mean in this case. When we talk of Venn diagram, is a pictorial presentation of the sets. We are talking of this one here. Sets are being read in such manner. Right, so this time around, let us stop here. But we need to meet again when we are going to look at another category of problems that is about now a 3 3-set problem. This is about a 2-set, as you can see. Next, we'll have 3-set problems in the next video. Thank you very much.